Hello, and welcome to Renewable Energy Live. I am Sarah Walters. Today I'll be talking to you about wave energy. Did you know that 0.2 of the ocean's waves could power the entire planet? Wave energy is a renewable source of energy. Waves are easy to predict compared to sources like wind energy. But what is wave energy? Wave energy is the captured energy from the surface waves of the ocean or other large bodies of water. There are many ways of capturing this energy and also several pros and cons. Now we go to Hope on Scene to learn about the different types of wave energy converters.
Thanks, Sarah. I'm out here on the coast of Portugal here to talk to you about the various ways of making wave energy. The first system we're going to talk about is called the terminator, and terminators are usually perpendicular to the water. They're usually stationary and on the shoreline. This one here is an oscillating water column, and it's made up of a chamber filled with air, and as the waves flow into the chamber, the air is pushed out and through a turbine which generates electricity. The second system we're going to talk about are called point absorbers, and they usually work in farms where you have many of these point absorbers all over. And the way they work is they consist of a buoy and a body, and so they move separately according to how the wave is moving. So when the wave is up, the buoy will push the piston up and draw water into the chamber, which will spin the turbine, and then when the wave moves down, the buoy will move down and push the piston down, which will drive water out of the chamber and again turn the turbine, which generates electricity. Okay, so the third system we're going to talk about are called attenuators, which are multi-segmented structures which float perpendicular to the water. As the wave goes by, it moves the different arms which push against hydraulic rams inside the center right here, which pushes high-pressured oil through the hydraulic motors, which generates electricity. They're connected to the seabed with a long cable, which the electricity runs from the generator, and they usually are over 140 meters in length and 3.5 meters in diameter. The last device we're going to talk about is called an overtopping device. It works by allowing water to go up and over into a reservoir. The only place for the water to exit is down and through a turbine. When the water goes through the turbine, it generates electricity.
Can you tell us about the differences in these wave energy converters?
There is definitely a huge variation in the different types of wave energy. In fact, there have been estimates that there are up to 100 different conceptual designs. Which is probably due to the fact that wave energy is relatively new. It was developed in the 70s, but so far only one country has implemented wave technologies, which is Portugal with 3 attenuators. So far, because so few countries have invested in wave energy, scientists have yet to come up with an optimal design. So obviously there's a lot of variation between the different designs, but out of the 4 that I've talked about previously, the main difference between them is how much energy they produce. So the attenuators produce 1 megawatt per day, the terminators produce 1.5, the point absorbers can produce up to 11 megawatts but usually don't, and then the single overtopping device produces 11 megawatts. Back to you, Sarah.
Thanks, Hope. Now I'm going to talk to you about some of the pros of wave energy. Wave energy is green energy, so it could help improve our global footprint. Compared to other green energies, like solar and wind energy, it is easier to predict. Also, ocean waves are more dense than wind energy, therefore producing more useful energy. Along with being energy efficient, they are also area efficient. A wind farm occupying less than a square mile could power over 20,000 American homes. They can also be deep in the ocean, so they do not destroy the looks of our beaches or cause any problems with sound. Some of the cons of wave power is that it is fairly new, so we are unsure of the effects on sea life. At the moment, the cost of wave power is very high, but as wave energy begins to expand, the prices are expected to drop. Also, having machinery break deep in the ocean can be very costly to repair. It is estimated with the small amount of wave technology we have, it could fuel 10% of the world's energy consumption. So as you can see, wave energy is the future. Thanks for tuning in. I'm Sarah Walters.